All right, so open your notes to where it says intermediate value theorem, and I'm first of all going to tell you what it is, and I want to see if you understand it, right? So if I went up to, I don't know, Nathan, I said, Nathan, we're going to learn about the intermediate value theorem today. This is what it says. As long as f is continuous on a closed interval from a to b with f of a not equaling f of b, right? Then for all k such that f of a is less than or equal to k is less than or equal to b, there exists some c element of ab such that f of c equals k. Do you get it? No clue, correct? I need to make you understand that by the end of the hour, because that actually is the theorem. But now I'm going to take the calculus out and I'm going to give you it in a scenario, and it'll make a ton of sense, okay? Nathan, when I got up today, it was 67 degrees, right? And then I checked at lunch, and it was 82 degrees. Agreed? Then there must be at least some time between when I got up and my lunchtime such that the temperature was 70 degrees. You're nodding, correct? Has to be, because temperature is continuous. I can't hop from 80 to 92 without passing through all the other temperatures, correct? So it makes total sense that if I left and it was 67 and then I checked and it was 80, then for all values between there, 73, 79, there had to be some time that it was that temperature. Agreed? That's what I need to get you to understand, but we got to take the temperature out of it. So we're going to write the theorem as it stands while drawing the picture. So I'm going to write now what I said to Nathan, and he was like, what? I said, if f is continuous, so this is called the hypothesis. If f is not continuous, we don't get to draw a conclusion. It's like if I said, if you're wearing a red shirt, you get an automatic A no matter what you do. We immediately check to see if we've met that hypothesis. Am I wearing a red shirt? And they're like, crap, I'm not. You don't even care what I say after that. Agreed? But that's a hypothesis. If it's not met, it doesn't matter what I say. If you're wearing a blue shirt, anyone not wearing a blue shirt, doesn't matter what I say next, you're out. Right? So the function has to be continuous. That's super important on a given closed interval. So what that means is you have this function. We'll just go over here in the first quadrant where things are pretty. And I'm going to draw a continuous function on this interval. And I'm going to make sure that this isn't as important, so I'm not putting it in the theorem. But f of a can't equal f of b. Back to temperature. If I said to Nathan when I got up today it was 67 degrees, and then at lunch it was 67 degrees. Did it have to be 70 sometime? But could it have been? Yeah, see, it's not enough to guarantee, but it could have happened, right, Nathan? So we have to just make sure those aren't at the same heights. So let's put f of a right here. So there's a f of a, and let's put f of b up here. And let's do what it says, connect them with a smooth curve that I never lift my pencil. All right, so that's the situation. If you want to picture temperature, then this would have been at 6 a.m. when I left for work, and this would have been at 11 when I ate lunch, and it was 67 degrees, and then it went up to 80 degrees. But you can think temperature, you just can't write about it. That's what this is saying. So what it says is, if f is continuous on a closed interval, and we're not at the same height, then for all k, k is actually a y value, and that k is going to be between f of a and f of b. And I said that when I said it to Nathan. He just really wasn't listening because it's all about k's and f's and a's and b's, and it didn't make any sense. So then for all k, let's put ours right here. Okay, so for all temperatures between 67 degrees and 80 degrees, there is at least one time during the day, that'd be down here, correct? Agreed? One time during the day, mine is right here. Boom. It was at this time that I reached that height. Wouldn't you agree? We're going to call that C. That's what they call it in the theorem. At least one C. This little symbol right here is called an epsilon, and it means element of. So you can write in the interval, but that'll cover those words. So one C between these two, such that f of C, the temperature then, was equal to K. I have to get you so that you can use that and write that really well. And it's not that difficult. There's key components on here. One of them is the function has to be continuous, because if it's not, we can hop and I'm not guaranteed. If the temperature could hop from 67 to 70, it doesn't have to be 68. It could just jump over it, right? Also, if they're at the same height, then I'm not guaranteed. It's just maybe it could be. So let's try two where it fails, just so you can see the failure of the IVT. So here's a piecewise function. It's already graphed. Is there a value between -5 and 2 on the function such that the y value is 2? And the answer to that is yes, there is a y value there of 2. But this isn't guaranteed by the mean value theorem. Can somebody tell me why? I can't find it using the mean value theorem, and it's not guaranteed by it because it doesn't meet something. What is it? It's not continuous on the interval. Yep, right here. It doesn't guarantee it. It could happen, but it doesn't guarantee it. So we'll say nope, it does not. Why? Exactly what you said. The function's not continuous on the interval. We've got a big old jump there at -2, so I could not apply it. Okay, so continuity is a must. Also, the y value in question, which in this case is 2, has to be, look at this one, I'm going from -1 right here to 5. Is the function continuous from -1 to 5 along that blue route? It is, right? So this is meeting the continuity criteria. But the question is there a value such that you're up at 2 on that interval? Well, not at all. The blue and the red don't cross, and it'll never be 2. So the answer is no. Why isn't the IVT holding? Why is it? I just told you you're guaranteed. As long as it's continuous, you're guaranteed at least one time. As long as what happens? Look back to it. What does your y value have to be? Between these two. You're guaranteed everywhere between those y values gets hit, not outside of them. So keep those two in mind. You don't need to write on that because we're actually not going to be worried a whole lot about when it doesn't apply. But what two conditions? Number one, f must be continuous on the interval, and that's really important. There's a question this morning about how do I know if I use closed or open brackets? I'm always going to write it correctly. These should be closed. But some of you are messy writers. Raise your hand if you want to own it. I'm a messy writer. Yes, I agree with you. Yours isn't so bad. Pretty bad, right? I don't know yet. Yours is pretty bad, right? And you can't help it. It's fine. But what happens then at the AP reading is kids who are messy writers will maybe go like this. And like that, I mean, I don't know. They call it a parentha bracket. Like, you can't tell. So because of that, there's never points allotted to it. So I'm always going to write those intervals as they should be. Like at infinity, do you think you should be opened or closed? But look at what a fine difference that is, even with my hand. It's too hard to grade, so they don't care. But I'll always write it correctly. So it's actually on the closed interval, but if you did this, it won't be docked. All right? So it must be continuous on the closed interval, and that y value, you might want to point at it, that y value in question, in this case it's 2/3, and again, f of is y, has to be between f of a and f of b. If it falls outside of the parameters, I can't apply the theorem. All right, let's go take a look. We're already half done. It's a short lesson today. First thing you're going to do is for each, we're going to determine if we can apply it, yes or no. And then if not, we'll say why not. If we can, we're actually going to use it. So let's start. First thing you have to check, continuity. Is there an issue with the function f? Does it have a continuity issue? Somebody can answer me that. Yes. Where? You should know that too. -2, and you should know what kind it is by now. There's a vertical asymptote there, also called a non-removable infinite discontinuity. Perfect, right? I've got an asymptote there, but it won't affect my application of the intermediate value theorem. Why not? Not in the interval. So the issue's outside my interval in question. This only had 1 point of discontinuity. Remember, those are determined by denominators. So there's only one place, and it's not in my interval, so we're continuous. The next thing you have to check is, what was the temperature when I got up? That would be the y value of the first one. You just plug and chug. -4 over 1. It was -4 below. Well, what was the temperature 3 hours later at lunch? Well, I put a 3 in and I get a 0. That's my temperature range. Now I have to check, is my given temperature 2/3 between those two numbers? Yes or no? No, I can't apply it then. So we're going to say no, right? 2/3 is not between, it's too hard to write. If it is, you can write an inequality, but you have to use the words if it's not. 2/3 is not between -4 and 0. That's just, I couldn't apply it. All right, so there's 2 things you have to check to apply it. Are we good with the 2 things, Blake? So the next one says, same function, I changed the interval. So now the issue is different. This is still a no, but now why can't I apply the IVT? I just want you to know when you can apply it right now. Why, Ollie? What'd you say? The asymptote's now in the interval. Okay, so you'll say, nope, F is not continuous, but you have to tell me where, because F actually is continuous for all real numbers except -2. So telling me F is not continuous is actually a false statement. F is not continuous at what? X equals -2, and it's not because it's -2. It's because -2 lives in my interval. All right? What do you think? Do you get when you can apply it? Now we have to talk about how you write it. When the answer is yes, and you actually have to go find that value, that time of day that it's guaranteed to be 70 degrees. Then it becomes a little bit more work, but it's not difficult work. It's just sort of, all we needed last hour, we didn't need 2 examples. They were good with 1, they were rocking it, so might as well get you to work on the worksheet, right? So let's start, Daniel. First thing you're going to do, we have to determine if we can apply the intermediate value theorem. That function has an issue. Where's its issue? It has a vertical asymptote at x equals 2, also called a non-removable infinite discontinuity, but 2's not in my interval. So continuity is fair game. I'm good so far. The next thing I'm going to do is figure out, where was I at the beginning? That would be the temperature, the 67 degrees I said to Nathan. I need to just go plug and chug. -1 over, -1 minus 2. I'm sitting there with a dot at -1, -1/3, so a little bit below the y-axis. And then later on the function, specifically 1, I'm at 1 over 1 minus 2. So again, we're just plugging in. Boom. I now have to check, is the y value I'm trying to find between those two? Yes or no? Is my y value between, you're nodding, right? It is. So now I can apply it. Here's how you have to write your work. This is all just scratch work. It's me making sure I can apply it. You're going to say since. All right? So since Devin is wearing a red shirt, he gets an A. I get to, right? So my first thing is since F is what? What's the first thing I have to state? Continuous. That will get you the first of 5 points to be earned with writing these. Since F is continuous, on the interval from -1 to 1, that actually won't make you lose the point. You just have to state the continuity, but I like to be a little bit more detailed. Since F is continuous on -1, 1, boom. And then you're going to write with or and or something. You have to show me what these 2 values were. I need to know. What was the temperature when you got up? Because if I just said, hey, did it have to be 80 today? You'd be like, well, if I got up and it was 70, and what? Did I do something wrong? Is it 1/3? Thank you. That was so easy to fix. Thank you for fixing my arithmetic. You'll find, and if you were to ask my Calc 2 kids, what does LaRude goof up on? They'll say, never the calculus, but arithmetic errors are everywhere. I'm terrible with that. Anyway, they're just sloppy. Why do I do that? Don't you do it. All right, anyway, since f is continuous, with f of negative 1 equaling 1/3, so you're telling me you know these two things, right? That's 2 points. You have to reference this theorem somewhere, so I like to do it right here. I like to say it met both criteria, so the IVT, you might say, why do I have to write that? Because we're going to have 3 of them by the end of this semester. Actually, I think all 3 are first semester. They're all called existence theorems because they guarantee something exists, and they're called the IVT, the EVT, and the MVT. Do you think you might screw the 3 up? Yes, so there's always a point allotted because they want to know you know which one you're using. And omitting it tells me, I don't know, but today it's got to be the IVT because we know nothing else. But the IVT guarantees, now let's talk about what it guarantees. At least one time, if it was the temperature scenario, but we call it C. Do you remember where C was? Was C on the x-axis or on the y-axis? X-axis. Yep, so you're going to tell me that because that's actually where kids goof up. It's not between these two. My C is in this interval at least one time during that day such that f of C equals my desired value, negative 1/2. That's what I wanted to make sure it hit. But watch how you have to write. One more thing. This is plus 4. You have to tell me because it fell between my 1/3 and, what was the other one? Negative 1? Boom. And that can be equal or not. It actually should be equal. But if you leave those off, you don't lose the point either. So back to you, Nathan. In this scenario, right, this is the temperature when I got up. This is the temperature at lunchtime. Agreed? I'm only looking at this from when I got up to lunch. I'm asking you, does the temperature have to be negative 1/2? And you're like, yeah, because it fell between the two. That's really such an easy concept, but you have to write about it. So last one. This is how they appear oftentimes on the AP test. Oh, we didn't finish that last one up. Sorry. It said you're also supposed to, if you can use it, find the value that it guarantees. So I am guaranteed a y value of negative 1/2. Agreed? Technically, you're supposed to say f of c, c over c minus 2, but if you write x over x minus 2, it doesn't matter. Okay, so you do whatever you like. I actually kind of like just doing the x, but they always say find the value of c guaranteed. So we'll set the y value equal to. How do I solve it? It always goes algebra. This is solvable without a calculator. What do you do, Nate? By what? Oh, that would work, maybe. I would just do like 8th grade, yeah, why not, right? I'll get a negative c plus 2. I'll add the c over. I'm going fast because I'm doing like 6th grade work right here. So if you're like, she's going fast, what's 6th grade work? All right, did that 2/3 fall in my interval it was supposed to? It's supposed to be from negative 1 to 1. Did it fall in there? What if it didn't? I made an arithmetic mistake because the IVT guarantees at least one. Now, what if there were 2 answers? And it happens on your homework, like you're going to get a 4 and a 7. The way you decide which one, both, or neither depends on the interval. If you're going from negative 2 to 5, what's your answer? The 4. Okay? If you're going from negative 2 to 8, then they're both viable answers. It's at least once. You can get more than one. Got it? So let's go to the AP kind, and then I'm done. So usually what they'll do on an FRQ that references this is they'll have some real world situation. We do a lot with physics stuff in here eventually, particle motion we call it. So this is at given seconds that I'm charting the velocity of something moving. Do you know what velocity is, Caden? What's velocity? Can you give me another word for it? Oh, it is speed with direction. So this particle is actually going the fastest at 9 seconds, but it went backwards, still moving, right, here, but slower than here. It's speed with direction. It's telling you right here that velocity is a continuous function. Okay, so you've got the continuity handed to you on a plate. So nothing you need to show for that. Look at the table and I bet you can answer the question immediately. First of all, if the particle is at rest, because we're guaranteeing a time that the particle's at rest, what do you think that means? Yeah, that we're trying to figure out if the velocity was ever zero, according to this table. Continuity is important. You should look at that and know for sure. Did it have to be zero? Yes. At a minimum of how many times? Twice. Okay? Because how can I go from a 10 to a -2 without lifting my pencil, without crossing the x-axis? Right? I have to be. By the way, this is how any of you computer programmers, in your calculator, you know how you do calc 0 sometimes because maybe in pre-calc you had a function like this and you had to figure out what that was, right? So you go second calc and you select 0. Have you ever done that? And then they say, well, go to the left and do a left bound, and you hit enter, and then what does it say? Right bound. What your calculator's been programmed to do is basically the intermediate value theorem. It's searching between your two bounds and looking for a sign change. It's not actually looking for zeros. What's it looking for? And if it doesn't see one, so suppose Christian accidentally puts the right bar here, it'll say error, because it can't apply the IVT because it's outside of the bounds. So your calculator's actually programmed to do this. So we know it has to hit 0 in here somewhere and in here somewhere. Based on this question, I only need to justify one of them because it doesn't say how many. It just says, does it have to be at rest? So let's pick the first interval. Now, if Abby just writes yes, how many points will she get? 0. So we got to make sure we know. It's a pain to answer the question, but it's easy. What's the first thing you have to verify to get point number 1? Since what? Go ahead and tell me. Yes, gotcha. Got it. Since V of t is continuous. They told me, so I don't even need to say why. Since V of t is continuous. Next, you immediately looked at the table and you saw two things that made you go, it must have hit 0. What numbers did you see that you're like, it had to hit 0? You looked in and you saw the 10, and what else did you see? The -2, you have to write that. You have to say, well, I'm seeing that at 1 second in the velocity is 10, and at 4 seconds in the velocity is -2. These two criteria, right, need to be stated. Since it's continuous, and I'm noticing it's at 10 and -2, then you have a couple options what you want to write, but I always go with the IVT right here. I say the IVT, reference the theorem, guarantees. What does it guarantee? What do you think I'll write next? See if you get it. I've only done 2, so it might be a little rocky, but go ahead. What do you think, Gunnar? Give me a couple sentences, like a couple words. Guarantees at least 1, so you know that's in there. Could be more than 1, so let's get that on there. At least 1. Now I changed the function, right? It's now called v, and we're not doing f of x, we're doing v of t, correct? So it guarantees at least 1 what? T. Excellent. Who said that? Was that you? T. In which interval am I looking at? 1 to 4, right? Not 10 to -2. Those aren't times. Those are velocities. So at least 1 time in this interval, that's what I was looking at from 1 to 4, such that v of t equals 0. There's something missing on mine. Mine's currently a 4 out of 5. See if you can figure out what I need to add. I could have done it right up here. I could have said and then written all this, or I just put it at the end. That's just how I do it. What is mine missing? It's got one thing I need to write. What do you think? How about way in the back? Savannah. Mine needs one more little piece of information on it for me to earn that 5th point. What is it? There it is. And that 0 that I found, need to verify falls between. That temperature that Nathan needs it to be falls between the morning and the afternoon temperature. All right? So this assignment's due tomorrow. We're going to talk through, I'm going to take this headset off, talk through the first one. You'll need a calculator on a couple of them, but I'll tell you when you get there. So, 23 minutes. Actually, my clock's too late, so 23 minutes. Here we go, let's do number one together. We'll start it, and then I'm going to have you write it, and I'm going to grab somebody's and we'll kind of score it. On a test, I score these out of 5. How much? Which reminds me, I should have starred this right here. Boom. You need that blue part right there. You definitely need to know how to write that. Not doing this homework's deadly because you'll forget how to write it. Once you write it 3, 4 times, it'll be in your head. Let's go take a look at number 1. First of all, it says determine if we can use the IVT. So let's do that first. What's the first thing I will do? Check it for what? Continuity. Polynomials, no matter what their degree, are continuous everywhere. All a degree add does is add another curve in it, correct? So you really just focus on denominators, and if you don't see them, it's continuous everywhere in its domain. All right? So, f is continuous in my head, I'm going to check. What's the next thing I'm going to do? I'm trying to use it to verify a 0 on the interval from 0 to 1. So what will I do? Maybe off to the side. Go ahead, Liz. Plug it in. Yep, got to see where it is at the beginning. So do f of 0, that you can do in your head. What's f of 0? Negative 1, maybe throw it off to the side. So this function starting at negative 1, 1 below the y-axis, and at 1, where is it? 2. Now you should know, yep, it's got to hit 0, correct? But you cannot write that. Now we have to start it. I want you to write it and see how many points you can get. We can apply it. So that's the justify part. We're going to justify that there's a 0, and then I'll tell you how to go find it. I'll just kind of walk over. Try to do it without looking, which I don't know if many of you could right now. You haven't practiced it much. I grabbed Sebastian's last hour just because he was just sitting here and I read it. And he worded it differently, but he hit all 5 things. So yours doesn't have to be word for word. Let's see if we understand. Being absent on the day like today and then not watching the notes is a killer because it's such an easy concept and you'd have no clue what to do. And that's kind of how this course is all year. You'll never know how to do it before you come in, but the concept's usually fairly easy to understand. But it's not like other classes where you can just be gone and figure it out. Right? It really is. That's what I read for. Anyone want to volunteer to be our sample? Otherwise, I'm picking you. You want to volunteer, Nate? It's done. He does. Yeah. Nate said I will. All right. Let's see how he did. Let's grade it. I'm looking for 5 things. Let's see if he got them. On your test, how many points will be allotted to a question like this? 5, I'm telling you. Right? So there's no reason we should have to retake that or redo that. When I'm telling you, know how to list these 5 things. Are you ready? He wrote, since the function is continuous. I go, ding. I don't take points away on this type of question. You earn them. I go, ding, 1. On 0, 1. With f of 0 equaling negative 1 and f of 1 equaling 2. Ding, he told me he knows where they currently are. The IVT, thank you for referencing the theorem, and it's the correct one. Later in the year, you might say the MVT, and I'll go, ooh, wrong theorem. You know, but keep going, right? You know, the IVT guarantees at least one C element of. And he wrote negative 1 to 1. Did he earn the point? No. What interval? 0 to 1. It's kind of we're guaranteeing at least one time, at least one x, when the temperature is. So he's at 3, such that f of c equals 0, because 0 is between -1 and 2. Okay. 4 to 5 on your first try. Change that interval. All right? Now it also says to find it. So you need to write a little equation right there. You have to write x squared plus 2x minus 1, or c, or is it cubed? Or c cubed plus 2x minus 1 equals 0. You have to solve that. That's not solvable without a calculator. So you can go ahead and use a calculator. If it was an x squared, you could try to factor, but there's no way you're solving that without a calculator. It's kind of odd that you're going to use a calculator that's been programmed with the IVT to determine. So go and round it. If there's 2 in the interval, there's 2 that are your choices, but you're looking on the interval from 0 to 1. That function better cross the x-axis at least once. And I'll take somebody who gets it graphed and can tell me. It's got to be at least once. If yours doesn't hit the x-axis on the interval, you either graphed it wrong or your arithmetic was wrong. I just saw 0.453, but can I have a backer on that? Because you got it too, Kellen? All right, so and did it only hit once in that interval from 0 to 1? Yep, so one answer. What if it hit twice? If it hit twice on the interval, there's 2, right? But make sure you're in the interval. So go ahead and do the next one. You can just work, you have 15 minutes. You should be able to get the front done for sure. When's it due?
Tomorrow.
This one's due tomorrow because it shouldn't take you more than